Today we're going to be working on the exam review from pages 4 through 7. So if we take a look here at the first question, it says which pairs of figures have the same volume? And so if we take a look, the things that we're interested in here are, first we are interested in the base to see if the bases are the same. So here it shows us that both of these bases have a radius of 4, and then if we take a look, they also both have a height of 6. So when that is the case, we have what is called Cavalieri's principle, which tells us that even if the shape is slanted, if the base is the same and the height is the same, then they should have the same volume. So for the first one, since they have the same bases, the area of the base is the same, the height is the same, the answer to this one is yes. Yes, these do have the same volume. Alright, for the second one, if we take a look, it tells us here that the bases are squares. So the base of the first pyramid is a square with sides of 5, and the base of the second one is also a square with sides lengths of 5. So again, since these have bases that are equal to each other and the heights are the same, the answer to this one is also going to be yes. Oops. Let's just fix that up right there. So the answer to the first one is yes, they have the same volume, and the answer to the second one is also yes, that they have the same volume. Alright, if we move on to the next one, the next question asks us, it says, find the volume of each figure is revolved about the dashed line. And so if we revolve this about the dashed line, then we have to think about what type of shape we are going to end up with. So the first thing to do is we can draw a reflection across that line, and then we want to imagine that this is a three-dimensional shape. So this point at the top is still going to be at the top, but at the bottom it's going to be rotated in this manner, and we spin it around, and this shape here would now be a cone. So if we look at our formula sheet, we want to find the volume of a cone. So we're going to use our formula here, which is 1/3 the area of the base times the height. And so in the first one, the base is now going to be a circle. And so let's actually find the area of the base first. So to find the area of the base, which is our capital B, we're going to do pi times the radius squared. The radius of the circle at the bottom is the bottom of our triangle here, which is 5. So the radius is 5, so our area of our base is going to be pi times 5 squared, which gives us an area of the base that is equal to 25 pi. Now again, we're not interested in we're interested in it, but the question doesn't ask us for the area of the base, it asks us for the volume. So to find the volume, we are now going to take 1/3, multiply that by the area of the base, which is 25 pi, multiply that one by the height, which is 3. And so in this case, the 3's actually end up canceling each other out, and our volume here is equal to 25 pi. Since we are talking about volume, our units are going to be cubed, so the answer to this one is going to be 25 pi units cubed. And if we plug that into our calculator, this one doesn't specify if we should leave it in terms of pi or not. If we plugged it into our calculator, if it asks us to round, then our answer would be approximately 78.54 units cubed. For problem number 3, we have the same idea. This time we have a rectangle that we want to revolve around the dotted line. So this time we're going to revolve it horizontally. I would start the same way. We're going to draw in a reflection. Then we're going to think about which way we're revolving it. This time we're revolving it down, so we're going to draw in our curves this way, which would now give us the shape that is a cylinder. Now this cylinder is turned sideways, so in our formula, the 4 is going to be our radius, and the height is going to be 7, which is going this direction. I'm going to move the volume for the last problem out of the way so we have room to write this one. Alright, so this time we are now interested in finding the volume of a cylinder. So if we go to our formula sheet, again, you can look in your review packet at the beginning, there's a formula sheet, and this is the formula sheet you'll be given on the test. So this time we are going, volume is equal to capital B times H. In this case, the area of the base is a circle, once again. So the area of the base is going to be pi r squared, and again we said the radius is equal to 4, so we're going to do pi times 4 squared. And that gives us the area of the base now is equal to 16 pi. Once we have the area of the base, we now can use that to find the volume of the cylinder. So the volume of the cylinder is going to be the area of the base times the height. Again, since the cylinder is turned on its side, the height here is actually equal to 7. So now we're going to do 16 pi, multiply that by 7, and if we do 16 times 7, we should get, I believe, 112 pi. And again, because we have volume, our units are going to be cubed. So we're going to have units cubed. And again, so that is your exact answer. And if you want an answer as a decimal, when we plug that into our calculator, rounded to the nearest hundredths place, we would have 351.86 units cubed. Alright, so that's it for problem number 3. Going on to the next page. Alright, on the next page it says name the cross-section that is formed in each case. So the first one says we have a cone cut by a plane parallel to the base, not through the apex, which is the top. So this is not on your paper, but I put these drawings here at the bottom just to help us sort of visualize what's going on. So the first one tells us a cone cut by a plane parallel to the base. So the first thing we want to know is when we cut through a shape that's parallel to the base, as we are doing in A, as we are doing in C, as we are doing in D, as we're doing in E, anytime we're cutting parallel to the base, the shape that is formed is going to be the same as the shape of the base. So here, if we cut across this way, then what would happen is we would get a shape that comes out like this, and our cross section would look the same as the base, it just would be a circle that is smaller. So in part A, a cone cut by a plane parallel to the base would give us a circle for our cross section. We'll come back to B in just a second. If we go to C, a rectangular pyramid cut by a plane parallel to the base, again, if we cut going this way, it's going to be the same shape as what we have on the base. And so what happens here is that since the base is a rectangle, then our shape here should be a rectangle. And again, you can imagine cutting the top of this off, and we cut the top off, the middle part, if we cut the top off and we look at our new bottom that we have, it would look the same as the other bottom, it would just be a rectangle that's smaller. If it's a square pyramid, it's the same idea. When we cut through, we are going to get a square. And for part E, for a cylinder, once again, if we cut it straight through, it's going to be give us the same shape as our base, which once again would be a circle. Alright, so that takes us to our other two problems. Our other two problems are B. It says a cone cut by a plane perpendicular to the base. Well, if we cut perpendicular to the base, then the shape that's going to be formed is the two-dimensional shape that is the most similar to the shape that we have. So what I mean by that is if we were to cut this, if we cut this with a plane where our plane is coming down this way, the cross section that we're going to get has a point at the top and it's going straight across at the bottom. It's not a very good drawing here. Let's try to see if we can draw that a little bit better. So again, it would come across here and it would look like this, and it would look like this. So the two-dimensional shape that we would get here is now a triangle because we were cutting perpendicular to the base, so this shape is going to be a triangle. For this one, once again, a cylinder cut by a plane perpendicular to the base. So now once again we're cutting it this way, so when we cut it this way and we cut it across here and go up this way and we cut it across, the shape that is formed here is now a rectangle. So again, the thing to remember on these problems is that if it's parallel to the base, then the shape that we get is going to be the same as the base. If it's cut perpendicular to the base, then it's going to be the two-dimensional shape that most resembles that shape. So a cone, when you cut it, would look like a triangle, and a two-dimensional shape for a cylinder would be a rectangle. Okay, moving on to question number 5. What is the relationship between the volume of a cone and a cylinder if the cone and cylinder have the same radii and the same height? So for this, we want to look no further than our equation. So let's take a look at the equation for a cone, and let's take a look at the equation for our cylinder. And again, we're interested in the relationship between the volumes. So again, the volume of a cylinder is area of the base times the height. The volume of a cone is 1/3 the area of the base times the height. And so what ends up happening is you can see when we put these equations right next to each other, or right on top of each other, the difference here is that this one has a 1/3 in it and this one does not. So if we're interested in the relationship between the volume, if the radii and the height are the same, then they're going to have the same base, they're going to have the same height. The only thing that's different is the volume. And so you can see the cone has a 1/3 in the front and the cylinder does not. And so what that indicates to us is that the relationship is that the volume of a cone is 1/3 the volume of a cylinder. For question number 6, it's very similar. What's the relationship between the volume of a pyramid and a prism? So in a similar manner, prisms and pyramids are derived from the same formula, it's just the shape of the base is different. So once again, for a pyramid, we have the formula 1/3 area of the base times the height. And for a prism, we have the area of the base times the height. So once again, if the if they have the same radii and the same height, or in this case, I'm sorry, it doesn't have a radii, it says they have the same base area and the same height. So again, these parts are the same. The only difference is that this one has the 1/3 in the front. So once again, we would say the volume of a pyramid is 1/3 the volume of a prism. Okay, for question number 7. Question number 7 says a scoop of ice cream is in the shape of a sphere with radius 3 centimeters. Sorry, let me start again. A scoop of ice cream is in the shape of a sphere with radius 3 centimeters. Is placed in a cone that has a radius of 2 centimeters and a height of 9 centimeters. All right, I think there's something funny in the wording of that question, but so I copied a picture of our ice cream cone here. This is not on your paper, but I thought it might help us to visualize. And again, it tells us that the scoop of ice cream is in the shape of a sphere. So again, if you imagine that this sort of fits perfectly in there, it's a 3-dimensional shape, but this would be a sphere, and we can see here that from the middle, the radius going out this way would be 3 centimeters, and it's placed into a cone that has a radius of 2 centimeters and a height of 9 centimeters. So again, for the cone, let's pick a different color. For the cone, the radius is going to be 2 centimeters, and the height of our cone is going to be 9 centimeters. Now this tells us if the ice cream melts into the cone, will the ice cream overflow the cone? Show how you determined your answer. So basically what we're interested in here is we are interested in the volume of the ice cream, and we're interested in the volume of the cone. And we want to know if the ice cream melts into the cone, will the cone be big enough to hold it? So we are interested, let's first find the volume of the sphere, which is the ice cream. And so in this case, our volume is going to be 4/3 times pi times the radius cubed. The radius cubed is going to be 3 cubed. Alright, and if we multiply that out, it looks like we should get 36 pi which also comes out to approximately 113.10, and again it's volume, so this is going to be centimeters cubed. So that is the volume of our ice cream. If we want the volume of the cone, this time we're going to use our formula for the cone. And so in this case we're doing 1/3 the area of the base times the height. The base of our cone is going to be a circle, and again if we imagine that sort of going around, let's pick blue so you can see it better. Here's the top of our cone, looks kind of like this, and we have a radius of 2. So if we have the area of the base, it's going to be pi r squared. In this case that would be pi times 2 squared, which is equal to 4 pi. To find the volume of our cone, we are going to do 1/3 the area of the base. Again, this is our formula right here. 1/3 the area of the base, which is 4 pi, times the height of the cone, which is 9 centimeters. If we take 1/3 of 9, we get 3. 3 times 4 is 12. So this answer should be 12 pi. And if we convert that, we would now have the volume equal to, of the cone, equal to 37.10 cubic centimeters. Alright, and so our volume of the cone was 37.10 centimeters cubed. The volume of the ice cream is 113.10 centimeters cubed. So if the person doesn't eat any of the ice cream will not fit into the cone. So the question says, again, we want to answer the question being asked, will the ice cream overflow the cone? The answer is yes. Alright, and again, if you had to elaborate on that, you would specifically say that the volume of the ice cream is more than the volume of the cone, therefore it's going to overflow. Alright, number 8 is a continuation of number 7. It says the scoop of ice cream in item 7 has a mass of 124 grams. What is the density in grams per centimeters cubed of the ice cream? And so this takes us to, this is our first question involving density, and if you go to your formula sheet, our formula for density is that it's the mass divided by the volume. So in this case we are interested in the volume of the ice cream, which we found in number 7, and the mass. So all we're going to do is simply plug this one in. So we're going to have density equals the mass divided by the volume. The mass in this case is 124 grams, and the volume is equal to 113.10 cubic centimeters, and we're simply going to divide those. When we divide them, let's look. I believe if you plug that into your calculator, our answer should come out to approximately 1.096 grams per cubic centimeter. Alright, moving on to question number 9. Question number 9 says a movie theater sells popcorn in a pyramid-shaped box whose base is a square of side 15 centimeters and a height of 25 centimeters. What is the volume of the popcorn box? Okay, so once again we have to recognize the shape. It tells us it's a pyramid. In the exam review, they don't really give you a picture here. It may help you to sketch out a picture. I included a picture here at the bottom. So it tells us the base has a square with side of 15 centimeters. So we have 15 on each side, 15 and 15, and it tells us that the height, which would be from the apex straight up, that height would be 25 centimeters. So again, this is a pyramid, so to find the volume, we're going to use our volume formula. We start by finding the area of the base. The area of the base is a square, so it would be 15 times 15, which would be equal to 225. Once we have the area of the base, we're now going to plug that into our volume formula. So 1/3 the area of the base, which is 225, times the height, which is 25. And if we plug that into our formula, it looks like we get a volume that is equal to 1,875. 1,875 cubic centimeters. Make sure when you're solving these problems that you include the units. Remember, if we're just measuring length or distance or height, the units are just the units. If we're measuring area, the units are always squared, and if we're measuring volume, the units are always going to be cubed. Alright, in this problem it tells us the density of popcorn is 0.3 grams per cubic centimeter. What's the mass of the popcorn? So again, if we go back to our density formula, I don't think I included that one on here, but if we go back to our density formula, remember that we have that the density is equal to the mass divided by the volume. In this case, we want to solve for the mass. And so if we plug in what we have 0.03 equals the mass divided by the volume, which is 1,875. If we multiply that to the other side, we should get an answer here of, looks like, this is number 9b, 56.25 grams. For part C, it says when popcorn is popped, it is stored in a cube that is 25 centimeters on each side. How many boxes of popcorn can be filled from this container? Alright, and so in this case, it's stored in a cube that's 45 centimeters on each side. So now, once again, they are changing things up on us a little bit here. This time it tells us they're stored in a cube. So I didn't put that one on here, but if we were to sketch it out, we draw in a cube, it's going to be 45 centimeters on each side. So 45, 45, and 45. And so how many boxes of popcorn be filled from this container? If we're filling the inside, that is talking about the volume. So for the volume, we want to know how much will fill the inside of this shape. And so what we're going to do is first we need to figure out what the volume should be. So if we have a cube, to find the volume, we simply multiply the length times the width times the height. In this case, it would be 45 times 45 times 45, or 45 cubed. The volume, if it's 45 cubed, is equal to 91,125 cubic centimeters. And I'm going to move this page down a little bit, give us a little bit more room. And once we have our volume here, then what we want to do is we want to figure out how many boxes of popcorn can be filled from this container. So remember, we're filling, this is our container that contains all the popcorn. We want to fill up these the square prisms here with popcorn. The question is, how many of these can we fill up? So if we go back to our volume of the popcorn in the first part, the volume of the popcorn was 1,875 cubic centimeters. And so So this one had 1,875 cubic centimeters that it could hold for the volume. And our total volume is 91,125. So to figure out the number of boxes, the number of boxes, in this case we're going to take 91,125 and divide that by 1,875. And when we do that, we get about 48.6 boxes. So we could fill up 48 boxes completely, and we would have a little bit of popcorn left over. Moving on to number 10, it tells us the three figures below have the same volume. Find the missing height in each case. Alright, so the first thing we want to do is we want to recognize this is a rectangular prism. Again, to solve for the volume, we multiply length times width times height. In this case, just 6 times 12 times 3. If we multiply those three together, we get a volume of 216 units cubed. Since all of these have the same volume, we need to figure out what number makes the height so that it has the same volume as this one. So if we set up our equation here, we would do 3 times h, and that should equal our volume. And so our volume is 216, so we should have 216 equals 9h. And if we divide by 9, we should find that the height is equal to 24 units. For part B, it's now a rectangular pyramid, and so we need to use our formula for a pyramid. Again, for a pyramid, our volume formula from our formula sheet, 1/3 the area of the base times the height. So in this case, we're going to have 1/3. The area of the base is a rectangle, 24 times 2. So the area of this base is 48. So we do 1/3 times 48 times the height. And again, we're trying to figure out what the height is equal to. We know that the volume is 216. So we're going to plug that in right here. So if we write it out down here, we're going to have 216 equals 1/3 of 48 is 16h. And if we divide by 16, our height should be equal to 13.5. 13.5 units. Moving on to question number 11. Question 11, this tells us that we want to find the volume of each solid described. And so these are very straightforward problems, just plugging numbers into the equation. Alright, and so in the first one here, tells us we have a sphere with a radius of 6 centimeters. So again, this picture is not drawn for you, but I included it on here so we can have a better idea of what's going on. If we look at our formula sheet that I have at the bottom, to find the volume of a sphere, we're going to do 4/3 pi r cubed. So for the volume, we're going to do 4/3 pi times 6 cubed. If we plug that in to our calculator, we should get a volume of 288 pi centimeters cubed. This is an exact answer. If we want an approximate answer, our approximate volume here is going to be 904.78 cubic centimeters. For problem number 12, we have a cone. The radius of our cone here is equal to 5 centimeters, and the height of the cone is equal to 9 centimeters. So again, for the cone, we're going to use our formula here, 1/3 area of the base times the height. And so the first thing we want to do is find the area of the base. The area of the base is going to be pi r squared. And in this case, that would be pi times 5 squared. And that's equal to 25 pi. Once we have the area of the base, then what we're going to do is we're going to plug that back in order to find the volume of the cone. So our volume formula, 1/3 the area of the base, which is 25 pi, times the height, which is 9. 1/3 of 9 is 3. 3 times 25 is 75 pi. So again, an exact answer is 75 pi cubic centimeters, if we want to plug that in and get an approximate value, the approximate value for this one is 235.62 centimeters cubed. And finally, for number 13, it tells us that we have a square pyramid. So for a pyramid, we're going to use the same formula, just the area of the base is different. This time the area of the base is a square. Tells us the base has sides that are 8 centimeters. So this is 8 and this is 8. And then the height of the pyramid going straight down, that height would be 3 centimeters. So if we plug this into the formula, the area of the base is 8 times 8, which is equal to 64. And then if we plug it into our formula, we're going to have 1/3 times 64 times the height, which is 3. Well, the 3 and the 3, 1/3 and 3 cancel out, and we're left with 64. So the volume for this one is 64 centimeters cubed. All right, and I believe just one more problem to get us through page 7. And the last problem here on page 7 is another problem involving the volume. And so here it says a company is producing a special part for a machine. Part consists of a cylinder of tin, which is the white part, and that is inside of another cylinder made of copper, which is the shaded part. The part is shown below. What's the total volume of the entire part? So for the entire part, we're talking about the entire copper cylinder, including the part in the middle. And it tells us we may give our answer in terms of pi or to the nearest cubic millimeter. So once again, we're talking about volume. So volume of a cylinder, we're going to use our formula right here. So first we need to find the area of the base. The base in this case is a circle, so it has a formula of pi r squared. So in this case, we can do pi times 6 squared, which is equal to 36 pi. To find the volume, we now take the area of the base, multiply that by the height. In this case, it would be 36 pi multiplied by the height, which is 5. We multiply those two together. It looks like we should get 180 pi. And again, if you want to leave, it tells us you may give your answer in terms of pi or the nearest cubic. I'm not sure what happened here. Sorry. We get 180 pi millimeters cubed. So this would be an exact answer. If we want to multiply it out, it looks like we should get approximately, tells us to round to the nearest cubic millimeter, which is approximately 565 millimeters cubed. For part B, what is the volume of the tin used in the part? So again, the tin is the part that's on the inside, so it's going to be the same formula. First it's just a smaller cylinder. So for the area of the base here, we're going to do pi times the radius, which is 3 squared. So the area here is going to be 9 pi. And our volume is going to be the area of the base times the height. In this case, we're going to have 9 pi, and we're going to multiply by the height, which is 4. In this case, the volume comes out to 36 pi millimeters cubed. This, again, is an exact answer. If we want to find an approximate answer, then we can plug that into our calculator, and our approximate answer for this one, rounded to the nearest cubic millimeter, would be approximately 113 millimeters cubed. For the last question, C, it says, what is the volume of copper used in the part? Well, to find the volume of copper, we need to take the entire shape, and we need to subtract out the part that's made from tin, and that should give us the part that we want. So anytime we have a shape inside of another shape, the way that we find if we want to take out the parts in the middle, we have to subtract. So take the volume of the whole thing minus the volume of the part that we don't want. So in this case, we already have our two numbers that we want, we just need to subtract. So again, if we do this as an exact amount, we're going to do 180 pi minus 36 pi, and that should give us our answer, which is 144 pi millimeters cubed. Again, that's an exact answer. If we want to round to the nearest cubic millimeter, we can either subtract the two numbers that we had in parts A and B, or you can plug 144 pi into your calculator, and the answer we get should be approximately equal to 452 millimeters cubed. I believe that is it for our lesson today. Thank you for watching. Good luck on your final exams.